Hey, happy Star Wars Day. And I would like to introduce you to our rabbit. And his name is Rocky. And you might have seen him early on in the videos. And Rocky's here to help show me how strong the Force is with me. And so we're going to use the Force, a little magic. And you're going to have to help me to make a rabbit appear on top of your head. I bet you don't believe I can do that, but I can. And so I'm going to make a rabbit appear on top of your head. So you got to help me because my Force might not be strong. I'm not quite the Jedi Master yet. Okay? And so we're going to make a rabbit appear on your head. And you still doubt, but you'll see in a second. Okay? So we're going to maybe need some magic words. Maybe we should say, abracadabra. Did it work? Take your hand, put it on top of your head. Do you feel a rabbit? Not quite yet? Okay, we got to try better. We got to really use the Force. Okay. Abracadabra, alakazam! Yes! I see it! It's on your head! Put your hand up there. Do you feel a little hair? Hair, rabbit, huh? Did you feel a little hair? And in these days, since they don't let us go to the barber, you probably feel a lot more than a little hair. You probably feel a lot of hair. And right here, this guy is a lot of hair. Rocky, say hi to him today. Happy Star Wars Day. Yeah. So we'll let Rocky go back to whatever he does. And we'll get on to do some e-learning. So I'm glad you're here on this Monday. Okay. And it's a Monday, so that means get the attendance taken right away. And that also means we have new logic problems. I'm very proud of the number of people that did logic problems last week. And so it's just like old times. And so, except we don't have grade trackers, no quizzes, no tests, no grade trackers, and no more notebook scores for the end of the year. But you need to make sure that we got warm-ups on Khan Academy, and we have logic problems every week. And so you need to get them done. And get those turned in. And so the logic problems, whether warm-ups, logic, geometry, algebra, pre-algebra, all have the same logic this week. Your warm-ups are already there, 3 new ones that will tie in with what we're doing. And so we want to give you some logic problem hints for this first one. And so here we are. Whoa, kind of big. And so the first problem, you are going to make a path of 77 numbers. And you're going to go horizontal and vertical, and you're going to number them. And the first part of the path is 1, and the last part's 77, and you're going to go horizontal and vertical. You're not going to go diagonal. And we could call it a snake. We've done ones like this before. And the numbers on the outside tell you how many in that column are in the snake. So there's 3 here, and there's 3 here, but there's only 1 here. Okay? And so when we look at this, we're going to start making the path. Well, if there's 3 in this column, these 3 have to be part of the snake. And so it's in the snake, if you look up here, it does not like lay next to itself. It won't be right there, so you won't have 2 rows or 2 columns of numbers filled in next to each other, and even diagonally. But so what we're going to do is start numbering these. So the snake starts here and it goes 1, 2, 3, 4. Well, the snake's going to have to go here for 5. There are 3 used in this column. So it can't turn down because then it would touch itself and already lay against the snake. So it has to go up. So this is 6. Well, it has to turn. This is 7. Well, this is a 1. So that means all of these are not used. And then that means this is an 8. Okay? Well, there's 6 used. Now that doesn't mean all 6 are in order. It could go down, over, and then come back. Well, it might not do that because there's a 1 here. That means it's only going to cross this once. This 12 does not mean they're 12 in a row. It's just 12 total. Okay? So I have a few other hints, like this 0 means these aren't going to be used. And this 4 means all 4 of these are going to be used. A 1 means when you cross the path, you don't cross back. And so those 1s are huge hints. And so when we get here, there's a 3. 3 of these are going to be used. When we go across here, 3 of these, you're not going to use this one. This is just trying to trick you because it's a trap, like Admiral Akbar on Star Wars always said. And so that little thing, that's a trap. This one, you can't go down in there and get out, so that's a trap. And so several things, and you got to find your path, not diagonal, horizontal and vertical, to end up at 77 right here. And so make sure you can get that, okay? So that's going to be worth quite a few points. So make sure you kind of keep track of where the empty ones are and keep track of where the path for the snake is, okay? And then we got one more type of question here at the bottom we want to show you. Part is all just letter codes, and we've done ones like this before. This problem, there's 9 letters, and we're going to use the numbers 1 to 9. This problem is 5 letters. We're going to use the numbers 1 to 5. This problem down here, even across my face, is 16 letters, and so we're going to use the numbers 1 to 16. But let's give you some hints on these. We'll do this one together. If I'm using the numbers 1 to 5, you could write those out and cross them off if you wanted. And if cab adds up to 11, and B adds up to 7, and Abe adds up to 8, different letters in this problem. The last one we did while we were still at school, I remember those days, we actually had different letters use the same number when we had all our names. And there's several that had a value of 1. But this one, different letters are different numbers because we're using them 1 to 5, 1 to 9, 1 to 16. So when I write out 1 to 5, the only way to get an 11 is 4, 5, and 2. So that means 4, 5, and 2 for cab. Well, that means in B, the E has to be 1 or 3. Well, it could be 1, 1, 5. Or it could be 3, 3, 1. Well, which one is it? Preston? Yeah, because cab has 2, 4, and 5, and B is in cab, so B can't be the 1, so B has to be the 5. Well, if B's the 5, then E's 1. Well, if B's 5 and E's 1, down here, that would 5 plus 1 is 6, that'd make A 2. Well, if A is 2, 2 plus 5 is 7, that'd make C 4. Is that an explosive? Ooh, we shouldn't be talking about that. And so C4, and then D wasn't even in any of the words. Well, D, that's what's left over. And so it'd be 1, 2, 3, 4, 5. And so we did that one together. Now here you're using the numbers 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I got some hints. If you multiply any number times 2, it's going to be even. You multiply any number times 2, it's going to be even. That means D is even because 14 is even. G doubled is an even. So an even plus a what is an even? Well, that means A is even. E doubled, that's an I, but the letter's E. Oh, it's a trap, it's a trap. And so E doubled is an even. And an even plus an even. So Y is an even. These might not be even because you're doubling them. This doubled plus this doubled is an even. That means V is an even. And so there's some hints there on your even numbers. I think I pretty much told you all the even numbers. And then this last one, which is going to be the hardest, we want to give you one hint here because we just love to give you hints. And what you want to do is you're like, what are some of these words? Hassan, Salah, I don't know this. But look, this and this both have an H. They both have 2 A's. What's the only difference between those, Rosie? Yes, the N and the L. And so this one has an N, and so if you subtract all the things they have in common, the only thing that's different is the N and the L. And how much bigger, Rosie, is the N than the L? They're 15. The N is 15 more than the L. Well, if I'm using the numbers 1 to 16, then what would be that number? Bree? Yes! L has to be 1, and N has to be 16. And that is your hint from the Jedi Master. So all you Padawan learners, those are your hints on your logic problems. Make sure you get them done. I know some of you are like, I'm going to get them done Monday. I'm going to show Mr. Nyson. Just like old times, I'll have them done before the end of the day. And so I'm excited. And so we keep them to a front side. Just try to get them all in and send them in. And now let's figure out what we're going to do for the notes and the homework. For geometry today, but before we do, many of you might have wondered who was playing the violin. Well, that was our oldest daughter, Anna. And so Anna, of course, Anna and Noah came home from Bethel early when we all came home. And they just finished up their schooling. And actually, Bethel graduation was supposed to be this past Saturday. And so, of course, that didn't happen. They're scheduling that for August. But Anna's home, and she wore her cap and gown on Sunday, and we had a cake for, and so she's been playing the violin through all the way up, and she even played at Bethel and was the first chair there. And so we really all enjoy making music, and she's done a great job, and she's going to be headed off to the University of Indianapolis for physical therapy this fall. Hopefully we all get back to normal. And so, but she did a great job, and that was a picture from Sunday, and the sun was shining. So great job, Anna, on that. And so for geometry today, we talked about circles last week. And so on your warm-ups this week, I have one of them is circles, finding the center, the radius, and everything. So that'll be a good review for that. But then along with circles, part of analytical geometry, and this will help us out when we get to Algebra 2, will be ellipses and what they are. And their standard equation is very similar to a circle, but the problems tonight are on the handout. They come out of a different algebra book, and because they're not in our geometry book, but it is geometry. And so your homework is the back of notes 11 to 22, 24 to 28, and there's going to be things called finding the foci, finding the vertices, finding the covertices, and we're going to talk through all these things, and all these things are going to give you a huge benefit then in the fall. Okay? So we're going to take a look and try to get some of these notes taken and what an ellipse is and what it isn't. Okay? So an ellipse, this is notes number 122, I believe. And so an ellipse is the set of all points in a plane such that the sum of the distances from two fixed points is constant. It's always the same. I don't know what that means, but that's just like in class. I just write it down. I don't know what it means. But we will explain it, and in the end, you will get it all. So you have two fixed points. Those are going to be called the foci. And if we took a length of string, and just like if we were in school, we could put a nail on a board, and we could put another nail on a board, and we could take a string and pull it tight, and the red string, no matter where I put it, I could pick a point right here. The string is still the same length, and if I pull it, I could pull the point to here, I could pull it over to here, perfect at the top, and that would be the length of the string. I could pull it all the way over to here, and the length of the string would go from here to here. I could pull it all the way over to here. This is kind of interesting. The distance between the foci and then that plus this distance and then coming back to there, that's the same length. And so there's a little animation on Math Wolfram Alpha, and you can see it. You're looking up here. Look up here at this animation. And so you pull that dot, and it's always the same sum all the way around. And there's some great applications of this. If we were going to Washington, D.C., there is, in part of the old chamber, the House of Representatives, it's in an ellipse. And I believe it was always Thomas Jefferson sat here and John Adams sat here. And if we take any point of this, the sound bounces off the wall, and you can hear a whisper if you're at one foci and sitting at the other. And so it's called a whispering gallery, and you can Google that and look more stuff up about that. It is rather interesting. Okay? And so what we're going to do is we're going to graph one, and we're going to show you some formulas about this. But I got to shrink this down so you can see me, see this, and see everything. Okay? And so the general formula for an ellipse is x squared, not plus y squared, equals r squared. This time, that was the circle general formula. And the circle general formula, oh yeah, don't write that down. Remember, used to be, x minus a, because there's like a center to this circle. Well, there's a center to the ellipse also. So this is x minus a squared plus y minus b squared. And we could have that. And it's not going to equal r squared, it's going to equal 1. But the thing is, we're not going to call it a and b this time for the center. Why? It worked last time. So we're going to shrink down the eraser a little bit. We're not going to call it a and b for the center. We're going to call the center h and k. Well, why? Because the a and the b are going to be what this is divided by. And they're going to be the lengths. An ellipse isn't perfectly circular. And then emanating from the center are two lengths. And one is going to be a and b. But when we look at it, it's a squared and b squared. And it's going to be the distance along the x-axis. And b is going to be the distance along the y-axis. So my center now of it's going to be hk. That's going to be the center. So we're going to use a and b for something different. So this ellipse right here, we're going to divide by 225 because an ellipse always needs to be equal to 1. And don't worry, we can divide 9 and 25 into 225. And so 9 x squared divided by 25 is going to be x squared over what, Sarah? Yes, 25. There's 9 quarters and $2.25. And how many quarters are in $2.25, Sarah? Yes, there's 9 of them. And so this is going to be my ellipse. An ellipse is always equal to 1. And it's really cool. Notice how there's no minus anything here. So the center of my ellipse is 0, 0. And we are going to, from that, on the x-axis, not going out 25, on the x-axis, you square root to 25, and you're going to go out 5 this way, and you're going to go out 5 this way. And that's going to be the ends of my ellipse. Now this, y squared over 9, the square root of 9, Morgan, is 3, so we're going to go up 3. And we're going to go down 3. Now we call these the vertices and the co-vertices. The vertices are always on the major axis. What makes it the major axis? Because it's the longer axis. The major axis could be on the y-axis if it's longer that way, or the major axis is the major one, the bigger one. And so this is the major axis because it's bigger in this ellipse. But if we had it turned, then the y-axis would be. If the 25 was under the y squared, that would be the longer one, and that would have the vertices. And so the minor axis has the co-vertices. Now vertices are just points. So this is a vertices, 5, 0. This is a vertice, -5, if I could write, -5, 0. These are vertices. These are co-vertices, 0, -3, because they're on the shorter axis. And then this is 0, 3. And so how you draw this, though, you just kind of got to visualize the oval. And with a mouse, this is really bad. Now remember, not all this is like critical learning for our stage of the game. But for your future, you'll be like, oh yeah, I remember, I heard about ellipses, and I knew they weren't my ellipses. I knew what they were. And the next time you talk about it, it's like, ooh, I have an advantage, okay? So we found the minor axis and the co-vertices. We found the major axis. But an ellipse also has these foci. Those are the points where you'd pound the nail into the board, and you would connect a string, and the string would hit all this. Well, I'm going to tell you that the foci are here at 4 and -4. How'd you know that? Because the foci is really the half of the major axis becomes the hypotenuse of this right triangle. And so that's why we call this. This is like b squared, and this is a squared. But what gets tricky is we wouldn't want this to be c squared. No, no, no. What we call is the foci have coordinates of c comma 0. This is if the center is 0, 0. And the opposite is c comma 0 if they're on the x-axis. If they're on the y-axis, it'd be 0c and 0 opposite of c. But instead of a squared plus b squared equals c squared, it's b squared plus c squared to equal a squared. What? I'm so confused. Because to find the foci, the c distance is from here to here, and your a distance ends up being up here. So it's really a squared, and this becomes c squared. So to find the foci, really all you do is subtract these two. Listen, this is very important. To find the foci, you just subtract the two bottom numbers and square root it. That's all you do, without doing all this Pythagorean theorem stuff off to the side. Just subtract them, you get 16, square root it, and you get 4. That means that's length 4, and then you write the foci as ordered pairs. -4, 0, and 4, 0. The foci, a focus is singular, foci is plural, and you just subtract these two bottom numbers and square root it, okay? We're going to do some examples, okay? So don't you worry. We're going to get some examples here, and then we'll get to the homework. Shouldn't be too bad. It says, graph an ellipse and find its foci. Well, even on your warm-ups, you might say, you'll start with the graph, and then you have to name it, and then you don't have to make so many graphs. But remember, an ellipse has to be equal to 1. So the first thing you're going to do is divide by 64, each part. And so if I divide all these parts by 64, unlike a circle that equals r squared, on an ellipse you want to make it so it's equal to 1. So this is going to be x squared over 16. This is going to be y squared over 64 equal to 1. So the fastest way to do this problem is the center is 0, 0. And that's not really part of the ellipse. On your y-axis, how far are you going away from the center? What would it be? Jacob? Yes, you're going 8. You just square root. So on the y-axis, we square root this. And so my vertices, because this one's bigger, are going to be 0, 8, and 0, -8. And so 1, 2, 3, 4, 5, 6, 7, 8. Hopefully I counted that right. 1, 2, 3, 4, 5, 6, 7, 8. Now going the other way. What would we have on that? Grant? Yes, the square root of 16 is 4. And so we go over 4. We go over -4. And then I would roughly, you can do it better than me, you can't really use a compass, draw the ellipse. Now, where are the foci? Are they on the shorter axis or are they on the longer one, the major one? Christopher? Yes, they're on the major one. And the easiest way to find this is just subtract these two numbers. And what is 64 minus 16? Is it 58? No, it's 48. You subtract these two, and you get 48, and then you square root it. So you could get a decimal, or this simplifies to 4 square root 3. Not 4 comma 3. What are you doing? So this would be 4 square root 3. So the foci, since they're on the major axis, and the major axis is the y-axis because it's longer, it would be 0, comma, 4 square root 3, and 0, comma, negative 4 square root 3. But Kaya, if I type this into my calculator, what is the square root of 48? Square root of 48 would be like 6.9 something. So I'd be right about there. That'd be foci number 1. And this would be foci number 2. These are your co-vertices because they're on the shorter axis. These are your vertices. They're on the longer axis. These are my foci. Focus number 1, focus number 2. Okay? Ready for one more example? Let's look at the next one. The next one's not going to be centered at the origin. And so we're going to, let's put me up here. Okay? And so the first thing you always want to do is divide by 16. So if I divide by 16, I'm going to get it equal to 1. And I'm going to divide by 16. Well, this makes a 1 here. And this makes a 4 on the denominator. So where's my center? Well, the center is going to be negative 1, 4, 1, 4. Which one is it going to be, Arlene? It's going to be 1, then negative 4. And the warm-ups will help you with that. In case you do them backwards, you'll miss them and you'll have to do them again. So it's going to be 1, negative 4. My center is 1, negative 4. Now, what's over my x squared is a 4. So I'm going 2 from the center to the right and to the left. Then the 16, I'm square rooting that, and I'm going 4 from the center. And those, the longer axis is my major one, and those are my vertices. The shorter axis is my co-vertices. And if this is 4 and 16 to find the foci, you subtract them. Well, that's square root 12. But your foci are not at square root 12. They're not at 2 square root 3. They're 2 square root 3 up from this. And they're 2 square root 3 down from this. So if this is negative 4, it's negative 4 plus 2 square root 3, and it's negative 4 minus 2 square root 3. But that is my y-coordinate. So the foci ordered pairs are, I should change colors, I don't really want to write all this, is 1 comma negative 4 plus 2 square root 3, and 1 comma negative 4 minus 2 square root 3. Well, negative 4 plus 2 square root 3 is negative a half. Negative 0.5. So that foci is about right there. That's this one. And if I type in the other one, negative 4 minus 2 square root 3, that'd be around negative 7.5. And so that's going to be right about 1, 2, 3, 4, 5, 6, 7.5. It'll be right about there. Okay? And so, yeah. Oh, the half would be here. I plotted that one wrong. That's right there. It's like they should be in the same amount from the ends. And they should be. So it's about half in and half in. So that was wrong. So those are your foci. Okay? So let's give you some examples, hints on the homework, and you'll be good to go. Okay? So let's see what we got for the homework. Now on your homework, if we look at the next page, it says write an equation. So that's all you got to do. Remember, an equation is going to be x squared over the length of this squared plus y squared over the length of this squared equals 1. So this is 3. No, it's not. It's 6. We're going by 2's. So it's 6. Oh, I thought we were going by 1's. So 6 squared is 36. And y squared, we're going all the way up to the 10. So that's 100. So that is the graph of that ellipse. Done. Remember on 12, you are squaring the 9 and putting it under the x. You are squaring the 4 and putting it under the y. On this one, the center is negative 5, 4. You got to find the length of this, which is 5. Then you have to find the length of this, which is 7. And then square it and equal. Okay? Now here, we don't know the center. But you could just find this length and cut it in 2. And that's the length of that. And then you could find this entire length and cut it in 2, because that would give you the semi-major axis or the semi-minor axis. Okay? Here, your negative 5, 1's your center. We give you that ordered pair to there, and we give you that ordered pair to there. And here you'd have to find half the length, and here you find half the length. So your homework is 11 to 22, so there's 11 to 16, right there. And then going to 22, you're doing the same thing, but can you do it without a picture? Can you write an equation without drawing it? If your vertices are negative 6, 4, and 12, 4, how long is this line? Well, it's 18. Half of that's 9. 9 squared is 81. But is that going to be under my x or my y? My covertices, 12 and negative 4, those are 16 apart. But then half of that is 8. And so you want the half distance. Okay? Same thing here. Now here they give you the centers. And you work out to a vertex, you work out to a covertex. Okay? So you get all those. And then we have the last 4. Oh no. The last 4. This one, here's your center. The center is what? What is the center? Kaya? Yeah, 3, 2. And then from the x, you go out 6. And from the y, you go out square root 128, which is 8 square root 2. And you can get a decimal and estimate it. Okay? This one, your center is where? What would your center be? Tim? Yeah, negative 6, 3. And then from that, how far are we going out? On the x-axis, on the x direction, from that center. Jack? Yeah, we're going square root 50 out each way. And then we're going square root 72 out this way. Same thing here. Those numbers are not nice. Just kind of estimate it. And then here, find the center, go out square root 27, square root 64, find the center, go out square root 4, square root 75. But it says, find the coordinates of the center. I'll see that from the picture. Find the foci. Ooh, foci. Subtract these 2 and square root it. 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 And that is where your foci are going to be. Now the hardest one, I only gave you one. These last 4, like, don't give me all 4 of these. But I'll give you one. If we're in regular school, we'd be talking about this. Could you write this using your algebra skills? I hear you had a halfway decent algebra teacher last year. Could you write it in this form? Could you do that? Well, how would we do that? And so the way we could do that is I'll get rid of, whoa. Somebody's going to need a tourniquet if we do that. And so if we do all this, I could rewrite this. Put the y squared with the 8y. Put the 3x squared with the 6x. And it's like completing the square, if you got good memory. And we're going to put this minus 5 way over here. See, if I see these two guys, this is like a y minus 4 quantity squared. But if I squared it, I would need a 16. This one, if you pulled out a 3, you would get x squared minus 2x. Well, then you would know that that would be x minus 1 quantity squared. So that'd be a plus 1. Well, when you distribute the 3, that'd really be a plus 3. So then that's like, well, that's plus 19. So I have an equation equal to 0, and I would need a plus 19 over here, because you can't just be adding 19 to one side, you have to add it to both. Well, then I almost have it in my form. I have 3 times the quantity x minus 1 squared plus y minus 4 quantity squared equals, well, I want to move this 5 to the other side, so it really equals 24. But in the ellipse, I don't want it to equal 24. I want it to equal 1. So I divide everything by 24. And so then this becomes x minus 1 quantity squared over 8 plus y minus 4 quantity squared over 24 equals 1. Then it's in the form you want. You know your center is going to be 1, 4. You're going to go square root 8 out in the x direction from the center. You're going to go square root 24 in the y direction out from the center. And to find the foci, you subtract these and square root, and you're going to go that on the y-axis. Foci are always on the longer axis, okay? And so we have, I did make a handout for you. See, the people who don't watch the videos to the end, I don't tell them. But you watch the videos to the end. I got a handout for you. Perfect spot to show all your work for the graphs. The other ones you can put on your own paper, and then you got the graphs right here, okay? So, ellipses, these are not ellipses. Ellipses are like ovals, where the sum of the distance between the foci is always the same. And so, we miss all you guys. Hopefully, you're doing okay. And so, we're doing okay here. Make sure you get your homework turned in. You're doing a great job. Work on your logic problems. Get your warm-ups done. Some of you forgot some. Some of you are finally getting in the groove. That's great. And so, I'm getting a little better at the videos, trying to come up with new ideas. So, hey, we miss you all, and so we'll talk to you. Email me your questions, and we'll answer, okay? Bye-bye.